Assalamualaikum student. Today we are going to derive Schrodinger wave equation. Here we have two types of Schrodinger wave equations. One is known as time independent Schrodinger equation and second is known as time dependent Schrodinger equation. So what are time independent, time dependent? Time independent Schrodinger equation in which we have no any factor of time, and time dependent Schrodinger equation is that in which we have a factor of time but not a spatial component. What is spatial component? That is known as displacement. So now in this lecture we will derive time independent Schrodinger wave equation. We will start this equation from the simplest form of complex equation, complex wave function, which is as cos kx minus omega t. This wave is propagating towards the right, towards positive x direction. So here we have a minus sign plus iota sign kx minus omega t. ये वेव हमारे पास जो है कॉम्प्लेक्स वेव है, ये वेव पॉजिटिव डायरेक्शन में मूव कर रही है, इसलिए यहाँ पे माइनस लिया है हमने. सही है. नाउ वी हैव टू कन्वर्टेड दिस wave function in the form of exponential form. So we know that e power theta is equal to cos theta plus iota sin theta. So our wave function become e power iota, here we have a e power iota theta kx minus omega t. So we will get wave function in the form of exponential form, e power iota kx minus omega t. Now differentiating this equation with respect to x, we will able to take dawa, or also we have to take d, so we have to use del iota k e power iota kx minus omega t. Again differentiating, del square psi upon del x square is equal to iota square k square e power iota kx minus omega t. Because we have also a time is also a variable, so that's why we use del. टाइम हमारे पास एक वेरिएबल एक और मौजूद है, इसलिए हम यहाँ पे del यूज़ कर रहे हैं, क्योंकि ये जो साई है हमारे पास वो x और टाइम पे डिपेंड करता है. लेकिन अभी हम टाइम इंडिपेंडेंट श्रोडिंगर इक्वेशन ड्राइव कर रहे हैं, तो आप d भी यूज़ कर सकते हैं क्योंकि टाइम इंडिपेंडेंट है, टाइम पे डिपेंड नहीं करेगी. नाउ वी वांट टू राइट दिस इक्वेशन इन द फॉर्म ऑफ quantum variables. So one of the important quantum variable, we have a quantum constant which is known as Planck's constant. So we want to write this equation in the form of Planck's constant, and this is a wave equation, so we also write this equation in the form of momentum, which is propagating towards in the positive direction. So now here in this equation we have k is wave number, which is equal to 2 pi upon lambda, omega is angular frequency, which is equal to 2 pi nu, nu is frequency, t is time, x is displacement. Now k is equal to 2 pi upon lambda, multiply and divide by h, so we will get k is equal to h upon lambda into 2 pi upon h. Here we also write this as 1 upon h upon 2 pi. That's why, because since we know that h upon lambda is equal to p and h upon 2 pi is equal to h cut, therefore our k will equal to p upon h cut. Put in equation 1. This is our equation number 1. Now here we have also able to put iota is equal to -1, which is k square, and e power iota kx is equal to minus omega t. So this is our equation number 1. So put this value of k in equation number 1. 1 implies that here del square psi upon del x square is equal to minus p square upon h cut square psi. Now our p square psi is equal to, according to condition, we have to write this equation as h cut square del square psi upon del x square. This is our equation number 2. Now this is the equation of wave. We want to derive equation of wave. So in any wave we know that energy factor is also present. So now we want to use energy for this equation as E is equal to kinetic energy plus potential energy. Put kinetic energy is equal to half mv square and potential energy in the form of in the letter of v. Now we have to convert this kinetic energy in the form of momentum. So multiply this by multiply and divide this equation, this kinetic energy, by m. So we will get m square upon m. Here m square v square is equal to p square upon 2m plus v. This is our energy. Multiply this above equation energy with by psi. So we will get E psi is equal to p square psi upon 2m plus v psi. Now from equation 2 we will get E psi is equal to, on the place of p square psi we will put this value minus h cut square upon, this is 2m del square psi upon del x square plus v psi. So this is our time independent Schrodinger equation for one dimension, 1D. Now if we want to write Schrodinger wave time independent Schrodinger equation for 3D, so what we will do, we will write h cut square upon 2m del square psi upon del x square plus del square psi upon del y square plus del square psi upon del z square plus v psi. So this is our Schrodinger wave equation in the form of for 3D. Now if we write this Schrodinger wave equation in the most simplest form, so we know that we have del square is equal to del square upon del x square plus del square upon del y square plus del square upon del z square. Therefore we will get E psi is equal to minus h cut square upon 2m into del square psi plus v psi. So this is our Schrodinger wave equation, time independent Schrodinger equation for 3D. Thank you for watching this lecture. So in the next lecture we will derive time dependent Schrodinger equation. Thank you so much.